Saxon Advanced Mathematics, Lesson 97. Greetings, students. We're back from spring break if you're following along with me in real time. We are here. We are starting Lesson 97. This homework will be due on April 18th, so you still have a week to do it. Look, we're getting close to the end. But if you are preparing for Running Start next year, this will be our last week of regular lessons for Running Start students because you're going to start your preparation for that test, the placement test that will help determine where you should start taking college level math. So I will continue to teach because I know I have online students that are not going to Running Start. So I'll continue to teach up through 120, but for my students who are heading to Running Start next year, this is your last week of Saxon. All right, and in that note, before we get into this quirky little lesson we have today, what I want you to do is register for Running Start as soon as possible. And I'll explain to you why. But first of all, let me say that it's online. There is a relatively small fee. It might be like $30 or $40 compared to four-year universities. That's like nothing. And it has been taking, in recent years, it takes up to 3 weeks to get your student ID, and that's important because you need student ID to take the placement test. And you need to take the placement test if you're not doing this Running Start thing, just gaze out the window. I'll be with you in a minute. Okay, so let me back this up. You want to register for classes as soon as you can. College classes fill up on a first come, first serve basis, and so you want to register as soon as possible. And I'm not sure if this is still true, but the policy at Edmonds has always been Running Start students get first dibs on registration. So you want to be ready to go. In order to register, you have to have signatures from a high school counselor and a Running Start counselor, somebody at Edmonds Community College, which is, I'm assuming, where you'll be going, Kyle. In order to get those signatures, you need to be ready to put your schedule together about a week before, and that means you need to have your math placement so you know which math class to take. Please don't take gaps in your math education. Keep going till you get all your math classes done and then throw a party for yourself. But please don't take gaps in your math education. It just makes it so much harder to start again. So do you see what's happening? It's all backing up. In order to sign up for classes, you have to have the signatures. In order to get the signatures, you have to have the placement. In order to get the placement, you have to have taken the test. And in order to take the test, you have to have your student ID. So that's why I'm telling you right now in early April, sign up now for Running Start so that you'll have your ID, and when we go, all these dominoes will fall smoothly and you won't have any drama in your timeline, because that's the last thing you need. There is a lady named Anya. She works in the Running Start office. She's not a counselor or anything. She's like a administrator type person. She works in the Running Start office at Edmonds College is what we're calling it now. And I talked to her last year in great depth, and she asked me to make her phone number available to my students. Her number is 425-275-8064. And she invites you to call or text her if you have any questions. And let me give you a tip on Running Start that will make your life there much easier. At Running Start, they don't want to talk to your mom. They want to talk to you, the student. They're set up to deal with teenagers and young adults who are new to this world of figuring this kind of stuff out by themselves. But they want to help you figure it out. They don't want to just talk to your mom. So please call them yourself or text. Texting is fine. Reach out to her yourself, make that connection. Don't ask your mom to do it, but she stands ready to help you if you have any questions. And she asked me to tell you, she'll be nice to you, right? You can be brave. She'll be chill and cool, and she'll help you if you have any questions about getting registered for Running Start. All right, so please get going on that. I will remind you as we go, and it'll be fine. But just go ahead and get started on registering so we can get your student number to you as soon as possible. All right. Okay, come back if you weren't interested in that Running Start thing. Now we're ready to talk about this quirky little lesson called the Ambiguous Case. Okay, we know that every triangle has 3 angles and 3 sides, right? And we know that if you have an angle and a matching side plus one more side, you can solve it, right? And we know that sometimes we would get ambiguous results. Remember, law of signs has that thing where we're not sure exactly which angle, if it's the first quadrant angle or the second quadrant angle, but we would always look at the picture to resolve the drama, right? And so that's something that is important. We relied on diagrams to resolve those ambiguous angles. But the authors of Lesson 97 pose to us, what if we don't give you a picture? What if there's no diagram and you just have to tough it out for yourself and resolve this ambiguous business? So that's what we're going to talk about today, is how can we tackle these problems and resolve these ambiguous situations if we don't have a diagram. Like I said, this is like a quirky little parlor trick. It is not something we're going to build on. It's a really great exercise for logic and for using trig functions, but it's nothing that we're going to build on too much. All right? So let's start with an example. There are how many examples? There's only 2 examples in this lesson. Okay, so example 97.1. And here's what we're given. A equals 40 degrees. We know because it's uppercase, that must be an angle. Then we're told that little a equals 4. We know that this must be a pair, right? Big A and little a, this is a side, this is the angle. So this is a pair. And then we're also told that C equals 9. All right, so that, it's a lowercase, so it's one of the other sides equals 9. Now, just to blow your mind, and I'm not going to draw all these out because I don't want to waste your energy. There are 5 different triangles that we could create, and I'm going to asterisk that because sort of not, with this information. And John draws them all out for us. ignore this one for now. We could have a right angle. We could have this sort of a deal, right? Where this angle is bigger than 90 degrees, we can see where it kind of points off. Or we could have two different acute angles depending on how long this side is. All right. So the question is, oh, and then there's this option too, in which it doesn't even make a proper triangle because this side is too short given that angle and that side. So that's an option too. So what we have to do is we have to figure out which of these triangles we've got. We have to draw the triangle. And it might be this one where it actually doesn't even make a triangle. How do we know? Well, I'm going to show you. What we want to do in this is we're going to assume it's a right triangle, and we will use trig functions to find h, which stands for the height, or if you think of it in terms of trig functions, it would be the opposite side. And I'll draw you a picture in just a second. Okay, so there's our information. I'm going to copy that. A equals 40 degrees, A equals 4, C equals 9. All right, so what we're going to do is say, okay, well, what if this was a right triangle, and this was the 40 degrees, and we'll let that be the hypotenuse. Okay, we let, in all these cases, we let the larger number be the hypotenuse, right? This is side A, but we also know this is the height, right? It's if the spider crawls up here, drops a web straight down, that is the height of the triangle. So let's figure out what the height is and then go from there. So we can use trig functions to do that because this is also the opposite side. So we know that the sine of 40 degrees equals this side, which we're calling h, or we could call it a, but I don't want to call it a. We'll call it h over 9. It's the height of the triangle. All right, so let's solve, use calculators, and solve this and find out okay, we're calling this side A or H. So here's why I'm calling it H. So we're going to use trig functions and solve for this. And we find out, we cross multiply, we bring that up. And then we find out that H equals 5.79. That's the length of H. Okay, so now we know that in order for this to be a right triangle, which is the shortest value, never mind, subtract that sentence. We have an A value that needs to be opposite this of 4. If our height is greater than our A value, then we know there's no triangle. And let me try and explain that in a little more detail. Let's look at our 5 different triangles again. Don't look at this one. This one's the freak out. Notice that in all of these triangles, side A is opposite angle A, right? The shortest, the version of the triangles with the shortest length for side A is this first one, right? If we make it tip to back, it's longer. If we make it sloping down, it's longer. A right triangle will have the shortest side in that A space. So if We calculate the length of this side using trig functions. We find out that it has to be 5.79, but our side A is only 4, then we know it can't be a real triangle. It's this situation where A doesn't even come all the way down. It's too short. And we know that it couldn't be any of these kind of triangles because that A would have to be even longer than this one. And this one's not long enough. We need it to be 5.79 at a minimum, and it's only 4. So if it's not even as long as this one, then there's no way it's as long as those 3, and this is what we have for our answer. So this is our, we calculate our H and then compare H to A. That was our next step, right? So the first thing we did was calculate H, which is the height, right? Then we compare H to A. That's what we did here. If H is longer or greater than A, then we have no triangle. And that is our answer here. Our picture would look like this. This is 9. This is 40 degrees. This is 4. It's not long enough to go all the way down. And so our answer is no triangle. Kind of weird, right? And even though it's not an actual triangle, we can draw this weird little diagram and leave that gap there. Because we know that with a 40-degree angle and a hypotenuse of 9, this would need to be 5.79 in order for it to actually work as a triangle. But our A is only 4, so no bueno. All right, let's take our 3 steps and do another one. Same instructions. Draw the triangle and find the missing parts. This is 97.2. And we get that A equals 27 degrees. That's an angle. We get that little a equals 5. So they're a pair. And then we get one more side, B equals 7. All right, so again, we assume a right triangle and calculate H, which is the height. Okay, so we know that the right triangle would look like this. This number is the hypotenuse. We'll put that in here. I'm going to make that B, not an H. This is 27 degrees, and this is the height, right? And this is the lowest value we can have for this opposite side, because in a right triangle, this side is the smallest. If it was obtuse, or even if it was an acute angle here and it went up, that would make this line even longer. So that's why we consider a right triangle, is because that's going to give us the lowest value possible here. All right, so now we're going to calculate our H. This is step 1. So we know that the sine of 27 degrees equals H over 7. And then we calculate, I'm going to use my same steps. I did it differently. Oh no, calculate H. Beautiful. And we get that H equals 3.18. Step 2, we compare H that we calculated to A. What's our A value? It's 5. Okay, this time we have that A is greater than H. That's good news. That means we have a triangle. Okay? Beautiful. Now we have to figure out what our triangle looks like. So now, okay, if it was a right triangle, then H would equal A, right? Because when you have a right triangle, this side is the height of the triangle. Well, that's not the case, right? Our H is 318, our A equals 5. Let me put those side by side so we can see them, all right? A is not the same as H, so that means it's not a right triangle, all right? The other options would be, I'm gonna draw them on the other side. It could be let me go back to John's picture. We've ruled this out. Our A value is greater than H. So we know we don't have a freak child like this. We know that H and A are different numbers, so we know we don't have a right triangle. If H equaled A, then that would tell us that it's a right angle. What we know is that we have either an obtuse triangle or an acute triangle. So we're deciding between these two. So what we have to do is draw the two triangles. I'm going to draw them side by side-ish. No, that's side by side. 27 degrees is here. All right, now we know that the opposite side is 5, and we know that our other longer side, I didn't draw this well, because this side should be longer, but pretend that it is. We're going to call that one 7, okay? So now what we want to do is use our tools, our law of sines, to try to find some of these missing pieces. All right, so let's start by trying to find angle B, which we're going to call this angle right here. This is an obtuse angle. This is an acute angle. So if we can nail this down, this angle, that will tell us which of these two triangles we have. So how do we find B? Well, we've got a pair and a pair, right? So we say, let me just write this out so we know what we're doing. Use the law of sines to find B. B is an angle. So 5 over the sine of 27 degrees should equal 7 over the sine of B. Okay. So we rearrange that, right? We'll basically cross multiply and get this rearranged. It will be sine of B equals 7 times the sine of 27 degrees. I'm just doing cross multiplying here to rearrange and get this in a form that's calculator ready. And what we get is that B equals either 39.46 degrees, or if we subtract that from 180, it will be 140.54. This is 180 minus 39.46. And we know that's the deal with the law of sines. When you're solving for an angle, you have to consider the first and the second quadrant, and that's how we calculate the other number. Okay, so let's look at this one. If this is B, then it would have to be the larger of the two, right? It would be 140.54. And if this were our angle, then this would be the 39.46, right? These are the two different triangles. Those are the two different B angles. If we have two of these angles, then we can find the third one just by subtracting, right? Right? This would be up here, C, we'll call it C. And we just take 180 and subtract these two. This would be 12.46 degrees. And this C would be, subtract those two from 180, 113.54. All right. And then the last thing we have to do is find this third side, which we'll call little c, right? Side C. And so the way would we do that? We're going to use the law of sines again. This time we're going to be solving for the side. We already have the angle. So that's good news. So what we'll do is we'll use the law of sines. Let's stick with our 5 over the sine of 27 will equal c over the sine of this angle, and then we'll set up the same proportion with that one. So let me do that on the other page. This is long, isn't it? What we're doing is we're filling out the details on these two other triangles. We don't know which one it is. One or the other of these triangles is the truth, but we don't know which one, so we're filling out both. Okay, so what we said was we have 5 over the sine of 27 degrees equals c over the sine of, let's see, in the first triangle it was 12.46 degrees, right? There's our 12.46, and then in the other one it'll be 113. There's a decimal there, it's kind of small. 13.54. So let's do that. I'm doing a little dividing line here because these are the two triangles. 5 over the sine of 27 degrees equals c over the sine of 113.54. Right, and this is the obtuse triangle, and this is the acute triangle. And we cross multiply and divide so that we get c equals 5 times the sine of 12.46 divided by the sine of 27 degrees. This is just cross multiplying, just a little algebra to get this ready for the calculator. And then this one, same thing, cross multiply and divide away what we don't want. C equals 5 times the sine of 113.54 divided by sine of 27 degrees. And then we go to our calculators, and for this one we get a side C of 2.38, and on this one we get a side C of 10.10. Okay? So we're going to take this information back to our pictures. C equals 2.38. And in this one, C equals, I'll write it this way, 10.10. And now we have two triangles. There's no way to decide or to know which of these two triangles is correct, but we're able to find all three angles and all three side lengths using the law of sines for the two different possibilities. Wow, that was a lot, wasn't it? So these are our answers. Now this first one, where we found out that our height was longer than our side A, and so there was not a triangle. This is seeming kind of like a fun little walk in the park, wasn't it? So the first step in these problems is to assume it's a right triangle because that's the shortest length possible. Calculate what that height needs to be based on the pair that based on these two, and then compare the height that you calculated to the length of the side that you have. You compare H to A. H is the height, and A is the side you have. This is just kind of a fun, quirky little side lesson. Don't let it freak you out too much. All right? Yay, thank you, goodbye.